Welcome to the world of putting one thing on top of another. Stacking things, so to speak. In that way, a stack is actually pretty similar to its name. It's a list of things with one on top of the other. And because of this grouping, we can only add to the top, and we can only take from the top. Imagine you just moved, and you have all of your games and anime in a box that was just big enough to hold all of them stacked one on top of another. You open the box from the top, and how do you remove them? Well, you can only grab the top one, which was the last one that you had to have packed. Pretty straightforward, right? This is known as first in, last out, or FILO. Programming stacks work the exact same way. You have a special kind of linked list, but it can only be manipulated with the add last and remove last methods. But in Stackland, these are called push and pop. And you have to remember those even though they aren't super obvious. Push adds it to the top of the stack, and pop removes it and then returns it. There's also another method that we care about called peek. It returns the top object like pop does, but it doesn't remove it from the stack, so your order doesn't change just yet. Why would we want to use a stack? Well, from a technical perspective, a lot of our algorithms are based on the concept of backtracking. Imagine you're playing a game and you hit a dungeon with a few branching paths. Once you reach a dead end, you need to go back to the last spot it branched and then follow a different path. Each of these split points can be put on the stack so that you don't need to render the whole dungeon, just the paths connected to each of these branches. And we can use the fact that you can't teleport in the dungeon and skip a bunch of these nodes to know that we will always go back through the dungeon in the reverse order of how we initially went through it. So this ability to maintain a consistent, reversed order can be super powerful. We can't accidentally do math wrong when we're deciding where we need to render in the dungeon, render the wrong part because we accidentally skipped part of it. We always will get the last branch point every time we pop the stack. For our code demo, we'll focus on that reversing aspect. So we're going to start off with our Pokemon project, which is in the description below. Almost where we left off last time, except I've removed a lot of the print statements just to keep it simple. Now at the bottom of this main method, let's do stack of type string stack equals new stack, and don't forget to import that. Then we're going to do a simple for loop. For int I equals 0, I less than 3, I plus plus. Then do string Pokemon equals nationaldex.getI, then system.out.println Pokemon, and then finally stack.push Pokemon. Outside of the loop, we're going to do system.out.println stack.peek to see what that top value is, what we're going to get next really. Now a new loop, for int I equals 0, I less than 3, I plus plus, system.out.println stack.pop. And now we're going to go run that. And the print statements should be in the order of Bulbasaur, Ivysaur, Venusaur, 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 Ivysaur, Bulbasaur. A perfect mirror. And this lines up exactly with what we did. We looped through the first 3 Pokemon, pushed each of them to the top of the stack after printing them, and then we peeked to see what was at the top of our stack, the next one we're going to get back, and then we printed them in the order the stack returns, which is the reverse order. Now before I sign off, I want to give a little what's coming up with stacks. And that is that they're going to be incredibly useful when we start our algorithms videos. They're essential when it comes to some of our tree and graph algorithms. And one of their absolute best friends in the algorithm world is recursion, which if you've seen my video on that topic, you might kind of recognize how recursion works is pretty similar to how a stack works. And that's because recursion does use a stack. The call stack. Just a fun little today I learned to end the video. See y'all next time. Like, subscribe, and comment below what you want to see next or topics you'd like to know more about.